Good day, students. Today we want to discuss on the topic titled heat of reaction, represented by delta H, and also is referred to as the enthalpy change, is the amount of heat change involved in a chemical reaction when it takes place between the molar quantities of the substance as represented in the balance equation of the reaction. Let's see what we are trying to say. Heat of reaction delta H is the amount of heat change involved when a chemical reaction takes place between molar quantities of the substance as represented in the balance equation of the reaction. This can be represented mathematically thus. You can see delta H equals total heat content of products. That is sum of the heat content of the product, that is the enthalpy of the product. Let's say this is the product, and this is the reactant. You add the heat content, the value given to you, you add them together for the product and remove the reactant from it. That is minus total heat content of the reactant sum. This same sign of sum, sigma. When you have something like this, that's sum. Okay. Let's see example. Consider a chemical reaction where steam is passed over hot coal at 600 degrees centigrade to produce carbon 2 oxide and hydrogen. You see water, the steam, you see G, gas, small letter G, heat passed over hot coal, solid S, you see to represent coal to give us carbon 2, which is the gas, plus the hydrogen gas. Now, see delta H, you add the products, that is the heat content, you can see total heat content, the heat content of the hydrogen plus the heat content of the carbon 2 oxide, you add them together, you now subtract that of the reactant, that of the gas, exactly the gas, which is the steam, plus the heat content of the hot coal. Okay, you add them together and subtract the reactant from the product. Now, when the heat content, the total heat content of the product is greater than, that is, of the product is greater than that of the reactant, you definitely have the delta H, the change in the enthalpy change, to be positive, or the heat of reaction, any of the word, heat of reaction, enthalpy change, or the total heat content, you can see it, total heat content of the reaction. Is that okay? Total heat content. What we now do is that when you get the positive, is a sign of you that it is an endothermic reaction. Is that okay? It is a sign that it is an endothermic reaction when it is positive. But if the HP, the heat content of the total heat content of the product is less than that of the reactant, that means that delta H is negative, which is exothermic reaction. We have two types of heat changes. We have exothermic reaction and endothermic reaction. Now let's see what's endothermic reaction. It's the one in which the heat is given out to the surrounding, you see, for the reacting system, making the energy of the system to decrease and that of the surrounding to increase. Okay, the surrounding and the reacting vessel will become hotter. Let's see example. When you put, for example, ice block in the container, you see that it gains the heat. After gaining the heat, it melts. That one now falls under endothermic reaction. Is that okay? Because it was cold before and it was gaining the heat, that's under endothermic reaction. But when we talk about exothermic reaction, in which heat is given out, let me say you boil hot water and water is hot in the container. After leaving it for some time, see that it's giving out the heat. It was hot before, was giving out the heat. That's that one fall under exothermic reaction. Energy of the system decrease. Hot water is inside here, and when you now leave it for some time, it becomes cold because it gives out the heat to the surrounding. That's what it's saying, that is the one in which the heat is given out to the surrounding for the reacting system, making the energy of the system to decrease. Energy of the system will decrease after it gives out heat, and that of the surrounding to increase. The surrounding and the reaction vessel will become hotter. You can see surrounding vessel become hotter. Now let's see the graph to explain this. This is the energy axis. You can see ER, this EP, reaction, T is time, this is the energy. Let's now see when the reactant, you can see the reactant is higher than the product. When this line is higher than the product, you can see it comes down, the product is down, the reactant is up. That is an exothermic reaction. It's negative. You can see when it means that the reactant is greater than the product, and you now subtract EP. When this product is lesser than the reactant, you can see it's lesser, it comes down, and the reactant is up. That means that when you are subtracting EP minus ER, because you must say EP minus ER, that's the energy of the product minus energy of the reactant. Because the product, the reactant is greater than the product, it will give us negative value. Let's go to endothermic reaction. Heat is absorbed from the surrounding into the reacting system. Heat is absorbed from the surrounding into the reacting system. You can see the reacting system. Heat is absorbed. You put ice block inside this container. You see that it absorbs the heat. When it absorbs the heat into the reacting system, you see that it will start melting. It's giving the heat. That's endothermic. Heat is absorbed from the surrounding into the reacting system, making the energy of the reacting system to increase. The ice block, when it's melting, when you touch the ice block before it becomes very cold, chilled. But when you leave it in the container for some time, after gaining the heat, you see that it starts melting, the temperature starts increasing. That's it. Making the energy of the reacting system to increase and that of the surrounding to decrease. The surrounding and the reacting vessel become colder. You can see it. System A plus B gives us C plus D. It's absorbing heat from the surrounding. Energy of the system increase. Let's see the graph. The graph, you can see in this case the product line is greater than the reactant, and you know that we are going to get the delta H. Is that okay? The change in the temperature, in the energy change. You can see change the energy, the product minus the reactant. Since the product is greater than the reactant, definitely you have the positive value, and when you have the positive value, in that case you have an endothermic. That's an endothermic reaction. It's a sign of an endothermic reaction. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.